Okay, this is a continuation from the lesson from this morning, Wednesday the 16th of, actually Wednesday the 17th of June. Okay, we're now on page 12 of your congruency booklet. If you could please go to page 12, question 3, and we'll just continue from where we finished off in the last video. Now in this question, for each of the following diagrams, you are told to mark on those diagrams all the given information. You are also to prove that the two triangles are congruent and hence find the value of the pronumeral giving a reason, and all lengths are in millimeters. Okay, you may wish to pause the video and attempt the question and then restart the video when you are ready. Okay, we can start off saying identifying our two triangles. Remember, that's always the first step of your congruence proof. So in triangle AEC and triangle, now I'm not really sure which way this is going to work, so we're just going to say in triangle AEC and in triangle BED, I'm not sure if they are in corresponding order, so I can just write them in any order at the moment, but when I do my final statement down the bottom, they do need to be in corresponding order. We have to see what we've got now. So we're told that AB and CD bisect each other. So we can start with that. If AB and CD bisect each other, then AE will equal EB and DE will equal CE. So we can start with that. So we can say that AE equals BE, and the reason is that CD bisects AB. So in other words, CD cuts AB in half. That's what that means. So I'm saying that AE equals BE because CD cuts AB in half or bisects AB. Now we can similarly do this over here, that DE with the double dashes equals CE, and the reason that DE equals CE is because AB bisects or cuts in half CD. Okay, so we've got two pieces of information. We also know that we've got two intervals crossing each other, so therefore vertically opposite angles are formed. So we can say, well, also angle AEC is equal to angle BED. Reason is vertically opposite angles. Now you are not to write any abbreviations for vertically and opposite. You can write the abbreviation for angle because the symbol is an angle. You do not know that AC and DB are parallel, so you are not to include that at all in your proof, okay? The only thing that you know is that AB and CD bisect each other. And then you can also see vertically opposite angles. So it looks like we've got enough information here, and we've got side, angle, side. So therefore, triangle AEC is congruent to triangle. Now we've gone along the side with the single dash to the dot and then along the side with the double dash. So doing this in the same order, it's congruent to triangle BED, and the reason is side, angle, side, because two sides are equal. Yeah, two sides of one triangle are equal to two sides of the other, and the included angles are equal. So now part 1 was to mark in all the given information, part 2 was to prove that the two triangles are congruent, and part 3 is to hence find the value of the pronumeral giving a reason. Now we can say that therefore x equals 12 millimeters, because see, this 12 is opposite the dot here in the first triangle and the x is opposite the dot, so they are corresponding sides of congruent triangles. Okay, now for the next question. Okay, if you can please pause the video and attempt that question as well. Okay, in question B, we have to mark in any given information. Now we're told that PS equals SR, so I'm going to mark that in. And we're also told that QS bisects angle PSR, so we know that that angle there equals this angle there. So let's start with our proof, remembering the first step is to identify the two triangles. So in triangle QRS and triangle QPS, we know that we've got to be careful here. I've gone QRS and QPS. So RS is from the first triangle and PS is from the second triangle. So we know that RS is equal to PS, and that was actually given. It's actually given here. RS equals PS. Okay? Doesn't matter if I write it as RS or SR. If I'm going from the vertex to the S, from this vertex here to the S, I should do the same there and make that PS. Now that information was given. We also know that QS bisects angle PSR. So we can now say that angle PSQ is equal to angle RSQ. And the reason is not given. The reason is that QS bisects angle PSR. Okay? We also see that we have a common side here. That QS is common, you can write, or you can say QS equals QS, common side. And by marking out what we've got, we can see that we've got side, angle, side. Two sides are the same and the included angles are equal. So therefore triangle QRS is congruent to triangle. So I've gone along the side with no markings and then along the side with the single dash. So I do the same here. It's congruent to triangle QPS. And the reason is side, angle, side. Okay, in part 3, we have to therefore find the value of the pronoun rule. Now we can see that K here is opposite the double dash side, and so is 100. Or we can say that K is between the side with the single dash and no dash, and the 100 is between the side with the single dash and the no dash. So we can say that K is 100 degrees, is just 100. The reason is corresponding angles of congruent, just make sure I'm in the video here, corresponding angles of congruent triangles. Okay, and that's page 12 completed. We're going to now turn to page 13. Okay, this is page 13 of your booklet, and we're doing another 4 questions where we're proving sides or angles are equal using congruent triangles. So in the first, what it says up here is that if we have proven that 2 triangles are congruent, you have proven or proved that they are identical in every respect. This means that 3 sides and 3 angles of one triangle are exactly the same as the 3 sides and 3 angles of the other triangle. So let's look at this first example here. We have to prove that triangle DAB is congruent to triangle DCB. Hence we need to prove that angle DAB is equal to angle DCB. So let's start. In triangle DAB and triangle DCB, we know that AD is equal to CD, which is 15, sorry, not 15, it's 9 centimetres. So they're both equal to 9 centimetres, and the reason that is actually given on the diagram because the values are given. We also know that AB is equal to CB, which is 15 centimetres, and again, that was also given. And we also know that BD equals BD because it is a common side. Okay, and so therefore, triangle DAB, I'm just going to mark these equal sides. Triangle DAB is congruent to triangle, now you have to do it in the same order, along the side with the single dash and the double dash, single dash, double dash. It's congruent to triangle DCB, and the reason is side, side, side. Hence, angle DAB, this one up here, will be equal. See, DAB is between the side with the single dash and the double dash, and this is also between the single dash and the double dash side. So therefore, angle DAB equals angle DCB, corresponding angles of congruent triangles. Now, we've already done examples like this, so you should actually be able to do these on your own. If you can pause the video and attempt the second question. Okay, we're told that ABCD is a square, and that E is the midpoint of AB, and that F is the midpoint of DC, and we need to prove that triangle ADF is congruent to triangle CBE. Hence we have to prove that AF equals CE. So first we're going to prove that the 2 triangles are congruent. So let's start with our triangles. In triangle ADF and triangle CBE, we know that AD, now I'm going from that pointy bit of the triangle to the right angle, so I'll do the same here. AD equals CB, And the reason that we know that AD equals CB, because we've got equal sides of square, or sides of square are equal. Okay. Now, we also know that DF, now, we're told that E is the midpoint of AB and F is the midpoint of DC. So we know that DF, this length here, will be equal to FC, which is that those two will be equal. We also know that AE will also be equal to EB. The reason we know that all four of them are equal is that AB is equal to DC. Now we need to state that as well. And then we need to say that E and F are the midpoints of both sides. So DF is equal to BE. And the reason is that AB equals DC, which are equal sides of square, and E and F are the midpoints of AB and DC. Okay. Next bit, we know that angle, okay, this bit I think is wrong, it just needs fixing. Okay, in the next bit we can see the angle ADF, so angle ADF is equal to angle CBE. Look, and they're both equal to 90 degrees. We can see that the angles are marked on the right angle. We could write, that the right angles are marked on the diagram, but we could also say, we could put given because it's marked on the diagram, or we could say angles in a square are right angles. So we can say angles in a square are, just need to make some more room here, angles in a square are 90 degrees, or you could have put given there because it is actually, the symbols are indicated on the diagram. Okay, now just because we've got a right angle here doesn't make it RHS. We do appear to have side, angle, side, two sides in the included angle. Therefore, triangle ADF, and now I've gone along the single dash side and along the double dash side, that is congruent to triangle CBE, and the reason is side, angle, side. So hence AF is equal to, so I'm going from the single dash side there to the end of the double dash side there, so AF is equal to CE. Reason that they are corresponding sides of congruent triangles. Now, because the two triangles are congruent, we know that therefore these remaining third sides will be equal to each other. Okay, now please attempt question 3. You may pause the video, and when you're finished you can restart the video. Okay, let's identify the triangles first. So we've got in triangle ADE, and I'm just going to have a guess at the order, and I'm going to say triangle BCE. We know that CE, actually we'll just write the order that's given down here, that we have to prove that triangle ADE is congruent to triangle BCE. We should also actually read the information. It tells us that AB and CD intersect each other at E. We're also told that AD is parallel to CB. We're also told that CE equals DE. So you have to prove that these two triangles, ADE and BCE, are congruent. So let's start with our first step, identifying the triangles. Next step, CE equals DE. Now that was definitely given here, so we can write given. Okay. Now, we also know that these two lines, AD and BC, are parallel. So we've got angle AED, so this angle here, well, that's actually vertically opposite with this angle here, so we can do that as well. So angle AED is equal to angle BEC, reason vertically opposite angles. We also know that angle ADE, I'm just going to put an arc on that one, is alternate to angle ECD. So I'm going to put angle ADE is alternate to angle, actually do it the other way round, BCE, reason alternate angles. Now you cannot just state alternate angles. You need to state that they are on parallel lines, or to make it more simple, you just say AD is parallel to BC. Okay? So there's our three pieces of information. It looks like we've got two angles and a side. So therefore, triangle ADE, now I'm going from blank angle to arc to dot, so I do the same here, is congruent to blank arc dot. It's congruent to triangle BCE, and the reason is AAS. And now we can say hence AD, which is this side opposite the dot, is equal to this side opposite the dot, hence AD. And it also goes from dot to arc, so that is equal to BC, blank to arc. So AD equals BC, reason corresponding sides of congruent triangles. Okay, now for question 4 of page 13, if you could please pause the video and attempt this question. Now, we are asked to prove that triangle ABC is congruent to triangle DCB. Now, you'll notice that the two triangles are overlapping each other. So when that happens, it really is a much better idea to draw the two triangles separately, and I'm going to do that down here. That way there will be no confusion about which side lengths are which. Okay, so I'm drawing the triangles separately. Yeah, because you have to prove that ABC is congruent to DCB, so I want the big triangles, okay? I'm not trying to prove that the small ones are congruent, so DCB. So I've drawn them the same. You can see that BC is common, so I'm just going to mark that one in, okay? We can also, actually I'll do them with 2 dashes, because there's a single dash on AB and DC, so I'll put those single dashes, that AB equals DC. And we can also see that we've got a right angle given up there at A and a right angle here. Now that looks to be enough information. So I'm going to start with it. So in triangle ABC and triangle DCB, we know that AB equals DC, and that was given because there are markings on the diagram. We also know that BC equals BC because it is a common side. And we also know that angle D, oops, there's a little mistake there, that's not DAE. We also know, that angle BAC, so angle BAC is equal to angle CDB, and they're both equal to 90 degrees, and that was given. Okay, so therefore, we've got all that information marked here anyway, and I can even put it there. So therefore, triangle ABC, which is along the side with the single dash and the double dash, is congruent to triangle DCB. And the reason is that we've got a right angle, the hypotenuse, and another side, so RHS. Hence, angle DBC, if we look at where angle DBC is, it's this one here, and it's opposite the single dash side. So it will be the corresponding or matching angle to angle ACB. So angle DCB is equal to angle ABC DCB. Sorry, I've made a mistake there. That it's equal to angle ACB. Just checking. DCB is right angle, it was actually blank there, or along the side with no markings than the double dash side. No markings, double dash side, so yes, it does match up with that. So angle DBC is equal to angle ACB, and the reason is corresponding angles of congruent triangles. Okay, now that's the end of our examples. I now want you to go to exercise 10.9 in your textbook, and we're going to start from question 3. I'll just let you know which questions to do in a minute. Come in. Okay, now. Okay, all right, I'm going to have to. All right. I'm just going to just record here for 1 sec. I'm just going to speak for about not even a minute. Okay, I'm just finishing my video. Thanks. Okay, so I've now shown homework on the screen. It's exercise 10.9, question 3, A, B, C, D, E, and F. And if you could also actually that will be enough for now. What I will do, I'm going to do a video on some of these other questions. Actually, change of plans. The homework will just be exercise 10.9, question 3. And that's it. I will be posting another video. Okay? Please check your emails.